Okay, today we're going to graph reciprocal functions and graph translations of reciprocal functions. But first you have a warm-up to do. You're going to need to describe each translation in each of these 6 problems. So pause the video and write down your answers, then come back and check them. Of course, this one's up 2 units. This one's inside grouping symbols, so it's left 2 units. Outside grouping, so down 3 units. Inside, so it's right 3. This one's a little more complicated. It's down 5, left 4. And this one's up 7, right 10. All right, we're going to graph using a table of values. If you've got your graphing calculator out, this might be a good time to double check your work. In your function editor for y sub 1, you can enter in 1 divided by x. You'll see a graph that looks like this. Once you use your graphing calculator, you can also a second table to find some specific ordered pairs. A reciprocal function belongs to the family whose parent function is f of x is equal to 1 over x, where x cannot be equal to 0. That's a biggie. A branch is each part of the graph of a reciprocal function. The line x equals h is a vertical asymptote and is a horizontal translation. And the line y equals k is a horizontal asymptote and is a vertical translation. Okay, we're to graph y is equal to 6 over x. So let's do that in our graphing calculator. We're also to identify the x and y intercepts and the asymptotes of the graph. Also state the domain and range. These are our 2 branches. What do we notice? We notice that the x-axis and the y-axis are both asymptotes. There is no x or y intercept. The domain are all real numbers except where x is equal to 0, and the range is all real numbers except for y is equal to 0. Use a graphing calculator. Graph the equations y equals 1 over x and y is equal to a. We're going to do different values for a divided by x. How does the value of a change? How does the value of a change the graph? So first of all, y1, put in 1 divided by x. y2, let's put in 3 divided by x and compare the 2 branches. What we see here is that a equals 3 stretches the graph by 3. Okay, let's go in and substitute in y2 for 4/10 divided by x. Notice that this is less than 1. It falls between 0 and 1. So our blue line is compressed by 4/10. Now let's substitute in a -2. And what do we see here? But it's stretched by 2. And it's reflected across the x-axis. Transformations. These are some of our key concepts. So pause the video and take a moment to study the vertical and the horizontal translations, the vertical stretch, compression, and reflections. What is the graph of y is equal to 1 over x minus 3 plus 1, and identify the domain and range? Well, let's draw asymptotes at x is equal to 3 and k is equal to 1. So x is 3, k is equal to 1. So the vertical asymptotes at x equal 3 and a horizontal asymptote is where y is equal to 1. Now let's translate the graph of y is equal to 1 over x, 3 units left and 1 unit up. The domain is all real numbers except 3, because if we had a 3 in here, that'd make the denominator 0. We can't have that. And all real numbers except 1. Okay, let's write an equation for the translation of y is equal to 3 over x. Has asymptotes at x equals -1 and y equals -7. So since the asymptotes are x equals -1 and y equals -7, we know that h is -1 and that k is -7. Using the general form of a reciprocal function, we're going to substitute in a -1 for h and a -7 in for k, and then simplify. Very good. Let's do a little practice on our own.